go. All right. Lesson 6 is features of graphs. So we can identify important features of graphs of functions. So we're still looking at functions in this lesson, and we're going to explain what they mean in the situation. So these different features, we're going to talk about what they mean in a real world situation. And then we can use the terms horizontal intercept, vertical intercept, maximum, and minimum correct when we're talking about these features. Okay, so if you are at home and if you are still writing those, you can go back to the recording and get them later, but we're going to go ahead and get started. All right. So 6.1, walking home. It says Diego is walking home from school at a constant rate. I want you to underline constant rate. Okay, when it's saying that it's at a constant rate, that means like when I want you to think about that and you're thinking of a graph, I want you to know that it's talking about a straight line. Okay, you can see that on the graph that it's a straight line because the speed at which he was walking home never changed. So it was just like the same speed from start to finish. So it forms a straight line. Okay. Okay, because they use terms like this at a constant rate when they're describing like the slope of a line, so that you know it's constant. All right, this graph represents function D. What's the name of this function? D. Which gives his distance from home in kilometers, m minutes since leaving the school. Okay, underline m minutes since leaving the school. Okay, so this is our time. So that represents our input. And our output is going to be the distance from home. Okay, so they told us a lot of information here. So we have the name of our function. We have the input, which we know goes on the inside of our parentheses. So any number that's on the inside of our parentheses is going to tell us about what? The minutes since leaving the school. Okay, so he's leaving the school and he's walking home. And what my entire function is set equal to is going to tell me the distance from home. Okay, so you can see those same parts represented over here. Minutes since leaving the school, that's my x-axis. Okay, kilometers from home, that's my y-axis. And then we have our line because he's going at a constant rate. All right, it wants you to use the graph to find or estimate these 4 parts. We have done this. This is what we did in the last 2 lessons. So you know how to do this pretty well. I'm going to give you about 2 minutes to find these answers. Look, it says to estimate. There's some that's not going to be exactly on a point. So just kind of estimate about where you think it is. So some of you may have a few decimals off answers, but that's okay. All right, I'm going to give you about 2 minutes. If you finish before time, you can raise your hand. I can come check it. And then we will talk about it together. People on Zoom, send your answers to me in the chat so I can check your answers. All right, we have 2 minutes. Ready, go. There's the goals if you still need to write those down. Y'all need an extra minute to look at those last two, or do we want to talk about them? Let's talk about them. Okay, so here we go. I noticed while I was walking around that it didn't seem like we had any issues with these two. It was these two that were a little bit more confusing. So let's talk about it. So when we're looking at it, first things first, it tells me the name of the function, d, and that just tells me I'm going to be looking at this graph here, okay? There's nothing else on the graph, so I'm just looking at this one function line. All right, what does the number on the inside of my parentheses tell me? Tells me the input, okay? So that tells me the x value. All right, can y'all see that? Whoa. Okay. All right, so I'm going to be looking at when my x is 0. So I'm going to go to my graph. Here's my x-axis. I'm going to go to 0, and I'm just going to go until I run into my function. It's about right here. All right, so it says to estimate if you have to. So that's about where? It's about 2.25. I saw some people put 2.3. As long as you had something around that answer, you got it correct. Okay? Because you just go until you run into that function. Next, once again, we're looking at function d. This number on the inside of my parentheses tells me I'm looking at what value? The x value, the input. Our input's talking about minutes, so it wants to know the distance after 12 minutes. So I go to 12 minutes. Okay, I'm going to go until I run into my function. My function is about right there. It's right below 1. It's right below the 1. So about what is the distance from home? About 0.9, 0.8, 0.85, whatever. Okay. My book says 0.75. You know, whatever. I would think that would be 0.7, more halfway would be 0.75, but that's a good answer. That's a good estimate to me. Okay, now this is the confusing one. So let's look at it. I'm going to change colors just because. All right, so this tells me the solution d of m equals 1. So we know we're looking at our same function. Did they tell me the minutes this time? No, so we don't know how many minutes, but they did tell us the value that all of it is set equal to. What do we know? What is it called? What the whole function is set equal to? It's called the output. So this time they started out telling us the output, which is our what value? The y. So instead of starting by looking at my x-axis, I'm going to start by looking at my y-axis. Okay. So I'm going to look on my y-axis at 1. So I'm going to go to 1, and I'm going to just go until I run into my function. And it's right here. Okay. So if I look, y'all don't have to be this precise, but I'm just showing you what I'm doing. All right. So it looks like when my output is 1, what is my input? It looks to be about 11. So I would write that d of 11 equals 1. All right. Last one, same thing. They didn't tell me the input. What did they tell me? The output. So we want to know what the input is when the output is 0. So this value that it's also equal to, once again, is my y. So I'm going to go back to my graph. I'm going to go to my y-axis at 0. Okay? And I'm going to go until I run into my function. Where does it run into my function? At 20. So when my output is 0, how much time has passed? 20 minutes. So D of 20 equals 0. All right, so this activity was just kind of a little refresher on how to read graphs and answer questions about them in function notation, okay? So as long as we know how to break down our function notation, we can easily find those pieces, and the more we practice that, the easier it will get. Okay, so let's go on to this next one. We have a toy rocket and a drone, okay? So we have a toy rocket and a drone were launched at the same time. All right, so I want you to imagine those two toys, okay? We know how they kind of work, right? Toy rocket, it just shoots up in the air, and then eventually what does it do? It comes back down. Does it usually go straight up and then immediately straight back down? No, what's it kind of do? Do what? Yeah, it goes up, and then it kind of like falls back down somewhere else, right? Kind of like when you throw a baseball or something. All right, then we have a drone, okay? Those are more controlled, right? Because they're literally a controller. Okay, so how do drones take off? Do what? They're just sitting there and then they go straight up. And then what happens? It can fly around, it can stay in one place, and then what does it do? It comes straight back down. Okay, so kind of different, but that's how they work in the air. Here are the graphs that represent the heights of two objects as a function of time. Okay, since they were launched. There's that little phrase, as a function of. So what are our two variables?
The object and time.
Okay, what about the objects? The heights of the two objects and time. So between those two, which one is my output? The height, good. And so the time would be my input since they were launched. Okay, so that's a review all the way back from lesson like 1 or 2. I can't remember. So height is measured in meters above the ground and time is measured in seconds since the launch. Okay, so if we look at our graph, we can see there that time is on our x-axis, just like we said, and the height is on our y-axis. Okay, so it says analyze the graphs and describe as precisely as you can what was happening with each object. Your description should be complete and precise enough that someone who is not looking at the graph could visualize how the objects were behaving. So we already kind of did that, and now we're just going to put it into words. Okay, so let's look at these two graphs. So they've named them for us. They gave us D. What do you think that one describes? The drone. And what do you think the R describes? The rocket. Okay. So let's split up this little area down here so we can be organized. So which one do we want to do first, drone or rocket? Let's do the drone. Okay, so I'm going to do the rocket over here. Right, just for kicks and giggles, I'm going to write it as the function name. D of x, R of x. Okay. So it wants us to describe what is happening. So we're looking at the drone. Okay, so it starts here. The time has started. So what's happening? What does it do first? It goes straight up. For how long? 2 seconds. Okay, so let's write that down. Or you can just write little bullet points. Flies up for 2 seconds. Okay, so if someone who wasn't looking at these graphs, they could picture that, right? Okay, so we have the drone, it's flying up for 2 seconds. Okay, and how high did it get?
20.
So it flies up for 2 seconds to 20 meters in the air. So since we don't use meters, that's 60 feet. That's times
That's
3.
pretty fast over there.
Yeah, it really is. 60 feet in 2 seconds?
Yeah.
That's fast. Okay, so we just described this first section. All right, then what does the drone do?
It stays
It stays at a constant height of what?
20.
So what in our heads we want to think is that the drone's kind of like flying diagonally, and then it's flying in a horizontal line, and then it's flying diagonally again. But what's actually happening?
Just staying in the same
It's
spot
staying at the same height for how long?
for-
It's at the 5 seconds, it looks like. So for 3 seconds, it's staying at 20 feet, okay? So next bullet point. For 3 seconds, the drone stays at 20 feet. Okay, so we've described this little section. We've described this little section. Now we need to describe what's happening here. Now what's happening with the drone?
It goes back down.
How quickly?
2 seconds.
In 2 seconds, it goes back down to where? The ground. I think y'all said that, but I don't know. All right, so last bullet point takes 2 seconds to come back down to the ground. All right, so we can imagine what is happening here, what that graph looks like just by reading these bullet points, right? Okay, because we've included the input and the output, input and the output, input, output. All right, now let's talk about the rocket. Okay. So, rocket. What do you notice about the rocket? Where does it start?
At 25 meters.
Okay, so that is one thing we forgot to talk about with the drone. Where did the drone start?
On the ground.
It started on the ground. So, how did this rocket start off differently? Could have been on top of a building. It started off at 25 meters. Okay, so let's write that down. Rocket started at a height of 25 meters. Okay, so that word right there, started, tells us that's the 0. And then it tells, we have the height of 25 meters, okay? So then what does it do when they launch that rocket? It gradually goes up until when? Okay, so it's about right there, which is about the 2 second mark. Okay, so it gradually increases to how high?
45.
Okay, so Is it increasing at a constant rate? No, because what would it have formed?
Yeah.
It would have formed a straight line. Okay, so it increases its height to 45 meters over 2 seconds time. Mental note, it's not at a constant rate. All right, then what happened after that 2 second point? It started falling, okay? What do we know what happens eventually when we throw something up in the air? It's got to come back down, okay? So after 2 seconds, it stopped and fell to the ground. How long did it take to fall to the ground? 3 more seconds, okay? So after, wait, so we'll just say then rocket fell to the ground. Oops. Fell to the ground 5 seconds after it was launched. All right, good. Number 2 on the next page. Can y'all still see your graph?
Yeah.
Okay, good. So it says which parts or features of the graph show important information about each object's movements, okay? So we're not going to actually write anything on number 2. We're going to turn back to our graph and just like label and point out some of those important features, okay? So looking at our graph, let's look at the drone first. What are some important features that tell us like specific points of the drone and or rocket? Let's start with the drone though. What are some important features of it? They are all straight lines, but what are like specific points within that function where we know like what the drone is doing? For example, like right here. What does that point tell me? Like what can I visualize at that exact point? It's on the ground, okay? So that's like the starting point of the drone. The drone is on the ground, okay? All right, just looking at the drone then, what's another important part? The 2 seconds it's in the air. Okay, because I know it stopped increasing its height and it's done what? It's just kind of floating there. All right, so there's another important feature, and we're going to talk about what these names are as we go on. Okay, and then we get to this point right here after 5 seconds. What's the drone going to start doing then? It's going to start coming back down. All right, and then what do we know about this final feature of that drone graph? It's back on the ground. Okay, so just a reminder, this drone is not moving in like a trapezoid formation, right? It's going straight up, stopping, coming straight down. Get it? Does that make sense? Because this is just the fact that the lines are continuous because time is passing. And that's not its actual movement. All right, let's look at the rocket. Okay, someone tell me an important part of the rocket. The starting point. Do I have another? Oh, I'll just look. I'll just do it. It started at 25 meters. What do we know this point as? It's the same as this one. We've talked about it before when we're graphing equations. The y-intercept. Those are both of their starting points. It's their y-intercept. Or as our goal said, which I don't like this name, but it's the same thing. It's the vertical intercept, okay? Because it's the up and down one. That's what the book uses, vertical intercept instead of y-intercept. It's okay. All right, next important point of that rocket. When it hits the top, okay? What did that point tell us? It's the highest point of the rocket was in the air. Who knows what that point of a graph is called? You may have used it in other classes, or you may have talked about it in math before. I think that's what it's called in science. That's called the maximum, which makes sense. It's the highest point. It's the maximum point. All right. And then what's another important part of the rocket? When it hits the ground. Good. Yes, it's yeah, your maximum and your minimum is just any point on the graph that's the highest compared to the rest of the points on that particular function, and the minimum is the lowest point compared to the rest of the points on the function. So yes, that would be the minimum because the other side does start off higher. Okay. Okay, good. So those are just kind of getting us to look at some important features of the graph. And on this next activity, we're going to get into using function notation to talk about those important features and what those names are. Okay. So we did number 2. All right, we have 6.3, the jump. It says in a bungee jump, the height of the jumper is a function of time since the jump begins. So there's that phrase again, is a function of. So what are my 2 variables that I'm working with here? The height of the jumper and the time. Which one of those 2 things is my input? Time. My X. So what is my output or my Y value? The height. All right, so function H defines the height. So what's the name of this function? H. Defines the height in meters of a jumper above a river t seconds since leaving the platform. So the number inside of the parentheses is going to tell me how much time since the jump begins. And what it's all set equal to is going to tell me that person's height at that point in time. Okay, so imagine someone bungee jumping. What does that look like? You jump off. What happens? You fall and then you stop? No, what happens? You come back up. Then what happens? You fall back down and then slowly, what happens? You kind of stop and you're just hanging there. Okay, so here's a graph of function H followed by 5 expressions or equations and 5 graphical features. Okay, so those are all right here. So those are all different features of our graphs like we did in that first activity. Remember that? Function notation. Yep, we got all that. And then specific features of our graph. Okay, it says match each description about the jump to a corresponding expression or equation and to a feature on the graph. One expression or equation does not have a matching verbal description. Its corresponding graphical feature is also not shown on the graph. Interpret that expression or equation in terms of the jump and in terms of the graph of the function. Record your interpretation in the last row of the table. So it's talking about this table here on the next page. So they've got these 4 descriptions, but there are 5 points here, right? Okay, so you have to match those 5 notations and equations here, and then whichever one is not mentioned, you need to add them down here and then come up with your own description of that point. Does that make sense? So let's do the first one together. It says the greatest height that the jumper is from the river. So let's look at my graph. What is the greatest height the jumper is from the river? Where's the highest point on my function? 80. Okay, so that's right here. Okay, so that's the highest point in the, and it has to be based on the way they described it, okay? So since they described it as the greatest height, what do we know that's called when we're talking about the highest point on our graph? The maximum, okay? So we know we're talking about this term, so we can go ahead and write that in there. That's the feature. It's the maximum. Okay? So now we have to match that with its correct function notation, okay? So which one of those function notations matches that maximum point on our graph? So we're talking about the greatest height that the jumper is from the river. So we're talking about the height. So when we're talking about the height, what are we talking about? The output. So what is the output at this point? 80. I didn't circle it very well. It's at 80. So which one of those function notations tells me that the height is 80? The fourth one right there, right? Y'all agree? Because that's the output and it's 80. That's the highest point on the graph. So over here in our table, we're going to write h of t equals 80. So you're matching the description with the notation and then what that feature of my graph is called. Okay, so there's one of these on this page that the description is not there. So match all the other ones first, and then whatever's left, you come up with your own description for that particular point. Okay, it is okay if you mess up. Write in pencil. We're going to go over it together. It is okay if you get them wrong, but at least try to do it yourself. Okay, I'm going to give y'all 5 minutes to do this, and then we will talk about it together. 5 minutes. Ready? Go. Here we go.
Did you start the video?
I started the recording. Here we go. So first part, it says the height from which the jumper was jumping. Okay, so that's that starting point that we were talking about. Okay, so if we're looking at our graph, where did the jumper start jumping?
Wait, what?
Where did the jumper start jumping? Right here, right?
Oh, yeah.
Okay, so if we're looking at our points, we've already used this one. Okay, so I know it's not h of 4 because that really doesn't have anything to do with it. It's kind of between these two because it's like, oh, it's a 0, right? All right, well, a lot of people thought it was this one, but this is saying the height is 0. Is the height 0 right here? No. Okay, so if I look at this one, this is saying the time is 0 seconds. Is the time 0 seconds right here? Yes, so at 0 seconds, he was 80 feet in the air. Okay, so that's my expression, or yeah, my expression. Okay, and what point of the graph is that? The vertical intercept, or the y-intercept. Intercept. AKA the y-intercept is how we know it. Okay. C, it says the time at which the jumper reached the highest point after the first bounce. Okay, so we just jumped, we went down. Okay, here's our first bounce. We're going back up. What's the highest point that he got? He got about 45, right? So which one of those tells us that the height is 45? H of t equals 45, because we know whatever my function is set equal to over here, that tells me the height, and it says 45. If I looked here, that's saying the time is 4 seconds. Is the time 4 seconds right here? No. Okay, so it would be h of t equals 45. Okay, so we've already used the maximum. We've already used the vertical intercept. So what is this point called on my graph? What is this feature called? First peak in the graph. All right, D, it says the lowest point that the jumper reached in the entire jump. Where's all my pins at? Oh. Okay, so what is the lowest point that the jumper reached the entire time? It was at 10 meters. Okay, so that's right here. It's the lowest point. Okay, so which one of these two describes that point? H of 4, because at 10 meters, how much time was it? 4 seconds. That's right there at my 4-second point. Okay, so that would just have been set equal to 10. So H of 4 would be the expression. Okay, and what is that feature of my graph called? First dip. Okay, what is the only point that was not used, or what is the only expression that was not used?
Horizontal intercept.
Okay, the horizontal intercept. Which was h of t equals 0. Okay, so let's describe what's happening here. Okay, so that's the horizontal intercept, aka the x-intercept. That's where it crosses through your x-axis. If I'm looking at my graph, can I turn my page real quick?
Yeah.
If I'm looking at my graph, do we see a point where it's crossing through my x-axis? No. Okay, so it's not even on my graph. So how am I supposed to know what's happening here? Well, let's think of what's this situation is talking about. We're bungee jumping, right? So let's look back at our variables. It's the height of the jumper and time since the jumper begins. It defines the height of a jumper above a river, t seconds since leaving the ground. Okay, so if the height is at 0, which it is, we're not on the ground, where would we be? We'd be in the river, right? Okay, so if we jumped off this bungee jump and it hit at 0 feet, what would we be hitting? The water, okay? So at 0 feet, at that horizontal intercept, what's that jumper going to be doing? Hitting the water, okay? The jumper hits the river. Okay, now usually bungee jumping companies are gonna take care of that issue, but there are some where if you like stretch out your fingertips and can hit like the surface of the water and then it brings you back up. Okay, so yeah. So then it wants us to use the graph to answer these 2 questions. So I'm going to give you about 2 minutes. Talk to your groups, whatever you need to do to answer those 2 questions. 2 minutes. Ready? Go. So hopefully answering these will be a little bit easier than what we did in that first activity now that we've kind of done it a couple times.
Do you ever think like, who like invented bungee jumping, like, I'm gonna strap some cords to myself and see if it works?
Psychopath.
Like Sky, like skydiving, or like take my bed sheets and just jump out of the plane.
I have about 1 minute left.
Frisbee, would you bungee jump out of a hot air balloon?
I would go in a hot air balloon. I would bungee jump. I would not combine the two. Is that a thing? No, yeah, I feel like I would just drag the hot air balloon
Yeah,
down.
just drag the hot air balloon down.
I mean, I know it's a lot stronger than the weight of me or anybody, but in my head, I feel like I would just drag a basket down with me. Hot air balloon though. All right, let's look at it. So we have h of 0. So we want to know what the height is after 0 seconds. Someone tell me what the height is after 0 seconds. 80. All right, next one. It wants us to know what the height is after 4 seconds. What is it? 10. Good. Next. All right, these are the kind of confusing ones that we started with, but we know how to do it now. So when we have a function and it doesn't tell us the input, we know that what it's set equal to is my what? The output. So what is our output talking about for this function? The height. Okay, so the height is 45 feet. We want to know how much time has passed. So how much time has passed at 45 feet? 8 seconds? Is that what y'all said?
Yeah.
Okay. So h of 8 equals 45. All right. Last one. H of t equals 0. So it wants to know how much time has passed when that bungee jumper hits the river.
Would it be 0?
Is there ever a time, according to our graph, where the person hit the river? No, we can't see it. Okay, so well, t hat would have to be something. Okay, how much time has passed? According to our graph, we don't have enough information to answer it, so we could just say no solution. According to our graph, there's no solution. Because there's not enough information in our graph. All right, so we talked about some important features of graphs in this lesson. We talked about the maximum. Okay, we talked about the minimum being just like the lowest point, maximum is the highest point. Talked about that vertical intercept, the y-intercept. We talked about the horizontal intercept, the x-intercept, and how those terms can relate to an actual situation like bungee jumping or shooting off rockets, and like those are specific points and they have meaning to them. Okay, let's look at your lesson summary. What page is that on?
173.
173. Okay. It says the graph of a function can give us useful information about the quantities in a situation. Says, just basically highlight that whole first paragraph. Says some points and features of a graph are particularly informative, so we pay closer attention to them. Says let's look at the graph of function h, which gives the height in meters of a ball t seconds after it's tossed up in the air from the graph. All right, so this graph is showing a ball being thrown from some height. So we might be on like a hill or something. He throws it. What happens to the ball? It falls to the ground, okay? So it says the point 0, 20 is the vertical intercept. Okay, that's this point right here. Okay, aka our y-intercept, or the point where the graph intersects the vertical axis. Okay, this point tells us that the initial height of the ball is 20 meters. Okay, so we would use this function notation to describe it. You need a new one? I have some more. I have some highlighters on my desk if you need them. Okay, next point I have is 125. That's right here. What is that point called? The maximum. What does it tell us? Tells us the highest point on the graph. The value 25 is also the maximum value of the function. It tells us that the highest point the ball reached is 25 feet and that this happens 1 second after the ball is tossed. Okay. And then it says we have the point 3.20. All right, that's down here. What's that point called? The horizontal intercept, aka the x-intercept, a point where the graph intersects the x-axis. The point is also the lowest point on the graph, so it represents the minimum. This point tells us that the ball hits the ground 3.2 seconds after the ball is tossed up. So the height of the ball is 0 after 3.2 seconds, which we can write as this function, because h cannot have any lower value, 0. Any lower value. 0 is also the minimum value of the function. All right, last bullet point. Wait, just kidding. The height of the graph increases when t is between 0 and 1. Okay, so from this little section right here, the graph is steadily increasing. And then from 1 to 3.2, what's my graph doing? It's decreasing, okay? So it said, yeah, that's what's happening. Next. Because the intercepts of the graph are points on an axis, at least one of their coordinates is 0. The 0 corresponds to the input or the output of the function, or both. So when we're talking about basically what that says, which is a little easier to understand, when you're talking about your vertical or your horizontal axis, 0 isn't always going to be included in one of those because it's at the axis point. Okay, so like if I'm looking at my vertical intercept, my x value will always be 0, right? Always, forever and ever. If I'm looking at my horizontal intercept, or my x-axis, my y value will always be 0. Okay, because it's an axis. Okay, and that's basically what these bullet points are saying. All right, that is lesson 6.